As the web moved from static content to software as a service, or SaaS, it soon became apparent that many SaaS applications were solving the same problems over and over. For example, HTTP was already the established protocol for communicating on the web, so any SaaS app would have to receive requests via HTTP and convert them into some representation of what code should be called and what arguments should be passed to it. Similarly, early SaaS apps always had to return a viewable HTML page or image as a response back to the browser, and that response had to be properly packaged using HTTP. And when cookies were invented, SaaS apps needed a convenient way to generate and associate a particular cookie value with each specific user in order to recognize that user when they return to the site. The solutions to these problems are basically the same no matter what the app does. Now, we know one of the holy grails of software engineering is reuse. If many problems have a similar solution, you try to extract the common elements of the solution and package them in a way that makes it easy for others to use, like libraries. Another kind of reuse is to identify an architectural pattern, an arrangement of subsystems within a larger app, and then construct frameworks that facilitate building apps around that pattern. The framework can take care of some basic plumbing and connections among the elements, and can hide or abstract away the mechanics of tasks that aren't central to the app itself, like dealing with HTTP directly. In this module, you'll learn about one such pattern called ModelViewController, or MVC. This pattern originated in the field of human-computer interaction as a way to describe how control and data flow in interactive applications with graphical interfaces. It's important to remember that if you can design your app in a way that matches a particular architectural pattern, such as ModelViewController, using a framework that supports that pattern can save you a lot of tedious work and speed up the development of your app. But if your app isn't really a good fit for that pattern, trying to work against the framework can result in code that is awkward and difficult to maintain and enhance. That's why the module on service-oriented architecture emphasized thinking about your app as a collection of resources and operations on them. If we think of each resource as having its own model, controller, and set of views, you can see how a resource-based app would map easily onto ModelViewController. Indeed, a resource-based app design realized as an app on an MVC framework, like Rails, has been an enormously successful pattern not only for server-side SaaS development, but also for client-side development with frameworks like Angular for JavaScript. Now, although most SaaS applications on the web fit nicely into ModelViewController, remember that software architecture is about alternatives. By choosing to use the web as a platform for building software, we're choosing a client-server architecture over other alternatives because HTTP is fundamentally a client-server protocol. By further narrowing down to ModelViewController as the architectural pattern for the server side of our app, we're choosing not to use other possible patterns such as template view or front controller. Once you've mapped your application onto a suitable architecture, it's pretty straightforward to develop the app using a good framework. But mapping it to the wrong architecture can be costly. We'll see more examples of this principle of identifying and reusing structural patterns when we cover design patterns in a later module.